Okay, we're doing linear programming and talked about how constraints or limitations or restrictions that we would have on a problem to produce either profit or cost. And so I have graph number 1 for you from your guided notes. And this equation you have on your paper is y and 2,500. And we have to decide if it's going to be less or equal to or greater than or equal to. So if we look at this line, it's shaded below. So y would be less or equal to. For this line was x plus y, 3,600. And these came out of the words right above. It's shaded below. So it's less or equal to. And then for this one, it was x and 3,000. And you'll notice that it's shaded to the left. So it's less or equal to. And you can also see that from the words here where it says to prevent the loss due to disease, the farmer should plant no more than 3,000 acres. So it can't be more than 3,000. We can't go above that. No more than 2,500 acres of romaine. So we can't go above 2,500. And then for this one, at the very first sentence, the farm owns 3,600 acre fields. So we can't plant lettuce on 4,000 acres. All right, so these are all of our inequalities or a constraint. So all of these equations, or inequalities, would go in part B. And the other thing about these linear programming problems is that we can't plant a negative amount of acres. So we will always have that x is greater or equal to 0 and y is greater than or equal to 0. We can't plant a negative amount of iceberg lettuce and we can't plant a negative amount of romaine. We could plant 0, but not negative. All right, so then we're going to find all the vertices or the corner points of our feasible region, our shaded region. So we want to name this point here in green, that I have in green. So that would be at 0, 2,500. Then we have this point here. So we know that the y coordinate is 2,500. And it crosses with this line. So if we were to replace this y with 2,500, 36 minus 2,500 will give us 1,100. And then this point down here, we know x is at 3,000, and it crosses with this line. So if I were to put 3,000 in for x, y would have to be 600. Also notice, I forgot to say that these are solid lines, and that's why we have an equals underneath here for our inequalities. So once we get all of our vertices points, these are the points that are possible to graph. Okay, so for our lettuce, we can plant as many acres as we want to, as long as it's in this feasible region, this shaded region. However, if we want to maximize our profit, it's going to happen at one of these corner points. So the next step here in letter E is we're going to put each one of these into our profit equation. And if we go back to the words, it says that farmers want to plant iceberg lettuce, which will yield $200 an acre per iceberg, and romaine lettuce will yield $250 an acre. So that's going to be our profit equation. Let me scroll that down. So here in letter E, get there, our profit equation is 200x plus 250y. Remember, x is iceberg, y is romaine. We're going to take each one of those corner points and we're going to put it into that equation. So we're going to put in 200. So the first one was 0, 2500, so put a 0 in here. We're going to compute that out, and we got 625,000. And we're looking for the biggest number because we want the biggest profit. So this was for the point 0, 2500. Then we're going to put in our 1100, 2500. And that would have given us $845,000. And we're going to continue to do that for each one of our vertices. Okay, so once we put all of our corner points into our profit equation, we want to look and see which one gives us the biggest profit. And so 845,000 looks like that's the largest. And so what that means is that we should, or the Montana's farm, should plant 1,100 acres of iceberg lettuce and 2,500 of romaine lettuce to maximize a profit of $845,000. All right, here's number 2. Might want to pause so that you can read the paragraph. And then I'm going to come back and show you the graph. I am going to provide the graphs for you and ask you to write the constraints, list the vertices, and find the maximum profit. All right, so here is the graph. And we are asked to find the constraints based on the words that they tell us and based on the graph that I have provided. All right, so it says, for example, in the words, that Sasha can stock at most 80 pairs of skates on her shelves together. So 80 together, so x plus y, 80. All right, so we need to decide, is it less than or an equal or greater than and equal? So at most 80 pairs. So we are looking at less than or equal. Also notice I graphed below. And then let's see. Sasha orders skates once every 6 weeks and can order up to 50. So that means she can't go above 50 pairs of each type of skate. So we can't go above 50 on either one. Then we want to find our corner points. So we'll start down here. So for this one, this corner point would be at 50, 0. This corner point, well, if this is 50, when x is 50, what's y along this line? We're looking for the intersection of this one and this one. So you could do elimination, substitution. Substitution is going to be much easier in this case. So if we put 50 in for x, 50 plus what gives you 80? Well, 30. And then for this one, when y is 50, what's x? So if I put 50 here, x would be 30. This ordered pair here would be 0, 50. These are all of our corner points here in red. So you could list them over here. Then we're going to write the profit equations. It says that she makes a profit of $40 on each pair of adult skates. So we have 40x, since we let x be the number of adults, plus 20 on each child. So $20 on each child's skate. So we just recopy all of our corner points over here, just from These are all the possibilities in order to maximize the profit. Now remember, the thing that could happen is any point in here would make all the inequalities true, but if we want to maximize, it's going to happen on a corner point or a vertices. So we're going to take each one of these and substitute it into the profit equation and see which one gives us the largest. All right, so there we have it. She should stock 50 adult skates, 30 children's skates, so that she can maximize her profit of $2,600. All right, so for homework, you are supposed to finish this problem that I just did. So if you watch this, good job for you. You got a little boost there. And then you are supposed to complete number 5 and number 6 from your sheet today. Good luck. Remember, we have an ORQ tomorrow.